In this video, we'll look at how to solve a quadratic equation using the quadratic formula. So we've already looked at factoring and using factors to find the zeros of a quadratic. Not all quadratic equations are factorable though, so we can start looking at other strategies, and the quadratic formula is a good one. So here is a quadratic relationship, y equals 3x squared plus 2x minus 4. If we want to find the zeros or the x-intercepts of this, really what we're trying to do is to solve this equation, right here. We're trying to find the equation, solve the equation 0 equals 3x squared plus 2. So we were trying to find the zeros. Graphically, if we look at this, we could graph this equation and find out where the zeros are. So let's just have a quick look at that. That shows up right over here. So here is the equation. Here's the parabola, and we can move our mouse so we can see that the y value is 0 when x is negative 1.54 approximately, and when x is approximately 0.87. So we're going to actually look at how to find those values algebraically. So we use the quadratic formula for that, and just a reminder that the quadratic formula looks like this. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And just a reminder, when we do this and we're trying to find the a, b, and c, our equation is in standard form. The a value is the coefficient of the x squared term, the b value is the coefficient of the x term, and the c value is the constant or just the numerical value. So that's important. And then we can substitute all of our values in. So when we sub into the quadratic formula, we're just using the coefficients, so just the numbers, not the variables. So let's start this off. X equals negative b. So I'm going to put a negative. Our b value is 2, so negative 2 plus or minus the square root of b squared, so b squared is 2 squared, minus 4 times a. Again, our a value is up here. So 4 times 3 times c, and our c value is here at negative 4. And be careful of the negatives. I tend to use brackets around a bunch of stuff just so that we don't make any mistakes in signs and thinking that there's addition when it's actually multiplication. And then we have to divide by 2a, so don't forget our a value is here. All right, from here, we are going to go to our calculators and we're going to start working some of this out. Some of you might be very good at just plugging this all into your calculator in one go, which is fine. I'm going to show you how. I'm going to break it up and show you how to do it in little steps. But if you want to do it all in one go and you feel comfortable doing that, you're getting the right answers and everything else, then by all means go ahead. All right, under the square root sign, we have a 2 squared. So 2 squared is 4. I'm going to leave this minus sign here. And then we're going to do 4 times 3 times 4 and get 48, except that last 4 was a negative, so this ends up being a negative 48. And again, be very careful of the signs here. All of that's going to be divided by 6. And then we will simplify what's under the square root symbol. So we have a negative 2 plus or minus the square root of and let me just try to simplify this a little bit. We have a minus negative 48, so those two signs there will combine to give us a plus. So 48 plus 4 will give us 52. Oh, let me change color there. And all of that's divided by 6. Again, if you feel comfortable at this stage going to your calculator, plugging the whole thing in all in one go, then by all means go ahead. I'm going to split this off into two parts here. So we'll have a positive part and a negative part. When I say positive, I guess I mean we're adding the radical. So we'll do negative 2 plus the square root of 52. And again, if you want to go to a calculator there and figure out that value, you can totally do that. Divided by 6. And then we'll also have negative 2 minus the square root of 52. And all of that will be divided by 6. So this is x equals this, and also x equals this. I'm going to run out of room here, so we'll just slide up here. So on my calculator, I'm going to type in negative 2 plus the square root of 52 And then I'm going to make sure that I press the equals sign because I don't want to just divide the square root of 52 by 6. I want to divide everything. So I'm doing -2 plus the square root of 52, pressing the equals sign, and then I'm dividing by 6. And when I do that, I get x equals 0.86, we'll call it 869. That's for the first value, and the second value, again, I'm going to type in -2 minus the square root of 52, press the equal sign again, and then we'll divide all of that by 6, and we get a -1.54. So those are the x-intercepts of this quadratic relationship, which means that if we were to graph this parabola, we know that there's an x value, an x-intercept at -1.54, so -1, -2, -1.54, somewhere in here, and positive 0.869, which will be somewhere in here. The parabola opens up because the leading coefficient is positive, so the graph looks something like this. Now this question didn't ask it, but if we wanted to find the vertex, we know that the x-coordinate of the vertex is halfway in between these x-intercepts. We can add them, divide by 2, find the x-coordinate, and then substitute that x-coordinate right back into the original equation to find the y-coordinate. So that's how we can use the quadratic formula to help us find the x-intercepts or to solve a quadratic equation. Sometimes what you'll see though, you'll see that instead of having a -4 in this equation on the right, maybe that 4 is on the other side, and so we just have to collect everything on one side of the equation. So the quadratic formula only works if we're solving for 0, so we're solving the 0. So collect everything on one side, get it in standard form, and then you can solve from there. Hopefully that helps.